Hello, good morning. Hi, folks. How are y'all doing today? Welcome to the May Urban Updates. We are so excited to see you folks. So for today, we've got a really great speaker that's going to be coming to us all the way from Minnesota. Thankfully, she can handle being up at 8 a.m. and presentable for us at Central Time. But today we've got Natalie Hoidal from University of Minnesota Extension. She's going to be talking to us about soil health from vegetable farmers, what we learned from 100 farms. Little background on how we had gotten connected in that I went to Marble Seed Conference. I think it was last year, and heard her speak about a lot of the work that she's doing with small scale diversified farmers and high organic system growers, and just kind of some of the trends that she was seeing with those soils and with those growers. And so I'm excited to have her join us today and talk a little bit more about the work that she's been doing out there. So I will let Natalie take it away. Thank you.
All right. Thanks, Terry. It's nice to be here with you this morning. Uh, like Terry said, I'm an extension educator in Minnesota. I'm kind of the statewide vegetable crops person who does a little bit of everything. I work a lot with soil health and climate adaptation and emerging crops. And for the last, I guess, 4 or 5 years, I've been really focused on soils just as I've worked with urban farmers, kind of across the spectrum from really small scale growers up to, like 50, 100 acre vegetable farms, and just kind of consistently was seeing soil nutrient management and soil health as a challenge. And so in 2023, I led a team who did this project looking at soils at 100 farms. We just don't know that much about vegetable soils, especially, there's so much diversity across environments, but sort of similar practices from urban all the way to rural farms. And so we just wanted to kind of get a baseline to understand what's going on in these soils, what makes them unique, what are the challenges and opportunities for managing these soils differently. And so I'm going to share that work today. So I'm going to share my screen here. All right. So this project started with just like hearing some common narratives from farmers about soil health. So in high tunnels in particular, um, the NRCS has really invested in high tunnels over the last, 10, 15 years. And in Minnesota, we've gotten just from 2010 to 2020, there were like 700 equip funded high tunnels and a lot more since then. It's kind of become like the standard that every small farm has a high tunnel. I imagine it's similar in Indiana. I think across the country from that same time period, NRCS funded like 26,000 high tunnels or so. And so it's this really new kind of technology, and we don't know that much about the soils. But I was hearing from farmers that they get a high tunnel, things look really good for like 3 years or so. And then things are not looking so good. There's kind of this decline in productivity. People aren't super happy with their soil health in their tunnels. And so as more and more people are getting high tunnels, I really wanted to know, like, why is this happening? What is happening? How can we prevent this so that as people continue to invest in high tunnels, they don't run into the same challenges? Um, and there were like two kind of common hypotheses, I guess, that farmers had about why that was happening. One was that in high tunnels, we are just like really hard on the soil. We're asking a lot of the soil. We have really high production volumes in a small space. We're often succession planting many crops throughout the season. And so there's this idea that the soils just get tired. There's this depletion due to heavy tillage potentially and nutrient uptake. And then the second idea is that salinity builds up in tunnels. And then zooming out a little bit beyond high tunnels, there were two practices that I was really curious about. I guess, one practice really, and that was just the use of really large volumes of organic matter. And a lot of my work centers around climate adaptation. And I was seeing that something that often comes up is this idea that like organic matter is one of our best resilience strategies. Organic matter holds on to water, it holds on to nutrients. And so there's this kind of narrative that like the more organic matter, the better, which translates to the more compost, the better. And then seeing people using compost as a mulch. So deep compost mulch systems have gained popularity um, over the last few years. And I had just a couple of kind of horror stories, I guess, with deep compost mulch, where this really started, I think, in the summer of 2022, where I was working with a couple of urban farms that had used a deep compost mulch system. And so they were using like 2 to 3 inches every year over the surface of their beds as a way to essentially deal with weeds. And it was kind of an approach to like reduce tillage on diversified small scale vegetable farms. And these two farms, I went out to visit, they had planted, and like 3 or 4 weeks later, nothing was growing, not even weeds were growing. There were just kind of these like barren soils. It was very strange. Um, and we noticed that the soil was really dry. And also then we tested it and the salts were quite high. And so this really got me thinking about like what what's going on here? How can we, is this like a widespread issue? The salt accumulation, or just how can we do these systems better? So that was a long introduction to say that these different experiences kind of led to this 100 Farms project. So wanted to explore soil health trends and practices, look at fertility. I had seen, probably 100 or so soil tests at that point, just kind of when I was doing farm visits, people would show me their soil tests and say, like, what do you think of this? And I was seeing really high levels of phosphorus. So I actually come from like before I worked in agriculture, I was really doing aquatic ecology. And so I've always been very focused on phosphorus and water quality in our food systems. And I was like, am I just obsessed with this? Or is this actually more widespread? Am I just focusing on these like few case studies? Or do we have a bigger problem here? So wanted to look at phosphorus, wanted to understand soil health. And then I wanted to, beyond just like the challenges, get a better sense of what practices are working. What are some like cool soil health tests that we can do? So we put together this study, went to these 100 farms. This is a map of the farms. We had 17 educators that were part of this process. So they all got trained, and then we all went out to our counties, and I kind of filled in the gaps and did a bunch of soil tests at the farms. And then the farmers filled out surveys about their practices. And this map is really, I think, a pretty good map of like where the vegetable farms are in Minnesota. So, we've got some big gaps in the far north and in the far west. We just don't have a lot of vegetable farms in those areas, mostly, I think, due to population density. So the average farm, just so you can kind of compare how these farms look with the farms that you might work with. The average farm had been in vegetable production for 7 years and had 5 acres in production. Here's the team. So I'm going to just start with like the really big picture, the kind of bad news big picture. And that is the longer a farm had been in vegetable production and the more experienced the farmer, the worse their soil health was on these kind of big picture physical properties of soil health. So more experienced farmers had less organic matter. More experienced farmers and older farms had less aggregate stability and also had higher bulk density, so more compaction. And that was, so the red means there was like a significant effect, and then the gray is nothing. So that was regardless of farm size. So a really basic conclusion that you might draw here, and we'll get more specific, but a basic conclusion that you might think is vegetable production may inherently be hard on soil health, regardless of scale. The good news is that many of the practices that we looked at had positive effects on soil health in these systems. So if people were using organic practices, and there was kind of a spectrum. So I think I'm going to show a slide on this, but we had maybe 15% of people doing conventional farming, about 15% who were certified organic, and then a lot of people in between who are using mostly or exclusively organic practices without certification. And as people used more organic practices and became certified along that kind of transition, the more their soil health improved in terms of organic matter and compaction. Soil test frequency had no effect. We actually, cover crop use had a negative effect in this study. But we looked at, these are farms that haven't been in production that long. We were not doing these studies where we were like doing controlled experiments of cover crops. We were just saying, how often do you use cover crops? So it was kind of a loose, not the most robust measurement. We did ask people to quantify their tillage. So how often are you doing deep tillage, medium tillage, shallow tillage? Like how many times a year are you doing each of those things? And that was really the strongest driver that we saw here. So reducing tillage did have an effect on organic matter and aggregate stability. And then adding plant-based composts. We didn't see in this study the same benefits of manure-based compost or manure. But again, we were using this was not like a controlled study of inputs. It was just kind of this general, like, how often are you using those things? So vegetable production may be hard on soil health, but conservation practices do make a meaningful difference. So tillage was the most significant important soil health variable here. And what we saw was that generally more experienced farmers had more land, and they used more tillage. They used more intensive tillage implements because, you often have a tractor at a larger scale. We saw this shift from people just like using broad forks and small hand tools up to a little bit deeper tillage as they got larger. And then organic certification, here's just kind of a breakdown. And this is what we see really consistently in Minnesota. I have a feeling this is similar in other places where, although few small scale diversified vegetable farmers are certified organic, most of them are identifying as like using organic practices. But it was kind of interesting that we did see that difference where when people became certified, we saw a difference in their soil health. So that was just a kind of a little background, a little kind of big picture on soil health. But I am going to spend some time looking at really like kind of the main focus of this project, which was nutrient management. So you all have, I stole this graphic from you. You have this really beautiful soil health picture, the soil health principles. And these are like kind of the universally agreed upon soil health principles. And the thing that is not represented here is nutrient management as a soil health practice. And I guess as someone who maybe came to agriculture from more of an ecology background, I see nutrient management as a really critical part of soil health and broader ecosystem health. And I think this project really reinforced this. So when inputs are really tricky for small scale farmers, I'm not going to go really into this today, but I can share a couple of papers, I guess, that my team has recently published where we're really like interviewing beginning farmers about their nutrient management and soil health practices. And that most beginning farmers, including emerging farmers, so in Minnesota, and I think probably a lot of the folks you're working with as well, we have many farmers who are immigrant farmers with a lot of experience in other contexts who are just like, figuring out how to farm again in a new place. And so I work a lot with those folks and have done interview projects, focus group projects all around soils. And people are generally really good at assessing the physical health of their soil and the biological health of their soil. But nutrient management is just tricky because it's a lot less like You can't just like pick up your soil and look at it and get a sense of the nutrients that are there. And for the most part, when we have a group of people who are trying to use mostly organic practices, we have more limited inputs. People are really using composted manure, and then some supplemental products. And it's just hard to understand the nutrient contributions that you're getting from those inputs. So in this study, composted manure was the most frequently used input. Over 50% of people were using it at least once a year. And then a lot of folks were supplementing that with things like blood meal, feather meal, etc. Vegetable compost was next. Few people using fresh manure. Um, 15 to 20% of people using synthetic complete fertilizer. So that would be like a 10-10-10 kind of product or a 19-19-19. And then fewer people using synthetic nitrogen. So mostly people are relying on composted manure and compost products. And when we asked people how they're making decisions about fertility, soil test was the number one thing that people selected. So they're taking soil tests and then, in theory, using that to make fertility decisions. That's followed by just observation, previous crop performance, talking to other farmers. Not a lot of people getting advice from extension, private consultants, co-ops, input stores. So really, people are doing soil tests. And in the kind of previous work that I mentioned with these focus groups and interview projects, and just hearing from farmers as I'm going around doing my job, we consistently hear, I do a soil test and I get the soil test back and I have no idea what to do with it. It's just a bunch of numbers and it's really overwhelming. And so we kind of saw that when we then asked, okay, compost and manure is the most frequently used input. How are you deciding how much to use? And even though people were doing soil tests and making some decisions based on soil tests, that was not really the thing that was driving their applications of compost and manure. For the most part, people were applying as much as they could get or a set amount, like an inch on every bed. And so that matters because we see significant nutrient accumulation on these farms. So 87% of high tunnels and 84% of fields had very high phosphorus levels. We use the metrics in our Minnesota Nutrient Management Guide for commercial fruit and vegetable farmers. And not only were most people very high, they were like really very high. So we measure phosphorus in two ways. I think do all use the Malich method? Do you use Bray, Olson, Malich? Okay, so we don't use Malich here. Our soil chemistry is just a little different. So we use either the Bray system when the pH is 7.4 or less, or the Olson system when it's above that. So it's a little awkward. We have two different maps of all the people with lower soil pH and then the people with higher soil pH. And I've put a red line on these graphs at the level that we consider to be very high, where we do not recommend additional phosphorus. And so not only were most people above that, but on average, people were way above that, especially in high tunnels where we're like 3 times as high, over 3 times as high. And you can see we have some outliers here, people with 600 parts per million phosphorus, 350. So really quite high. And that seems to matter. So when we look at Midwest soils, whether we're looking at Iowa, this middle one's Minnesota and Wisconsin, we've got Ontario here on the right. The horizontal x-axis is your soil phosphorus level. And then on the vertical axis, we have the amount of phosphorus leaving fields. So on the two sides, we're just looking at surface runoff. And in that middle graph, we have both surface runoff and tile drainage. And there's a pretty clear relationship in these studies that the amount of phosphorus in your soil is really a good predictor of the amount of phosphorus that leaves your soil. There's some debate about the threshold at which soil begins to lose phosphorus. But the main way soils lose phosphorus is when soil is leaving a farm. And so if we have a lot of soil runoff through erosion, if we have a lot of phosphorus-rich compost just sitting on the surface and maybe more likely to move, those are all risk factors. And then having clay soil is another risk factor of phosphorus runoff. So yeah, again, higher risk in kind of heavier clay soils or soils that are very compact, that don't have good infiltration, which our urban soils are often very compact, even if they're not necessarily clay texture. And in urban areas, I think there's this especially high risk because we have storm drains all over that just go straight into our rivers. And so the likelihood that phosphorus actually, if it moves, makes its way into a waterway becomes higher when you have storm drains all around the area that you're farming or gardening. So we expected high phosphorus. And in part, that's because when we're relying on things like composted manure or compost, we have relatively high phosphorus and potassium levels in relation to nitrogen. And so we're always trying to meet our crop nitrogen needs. Our plants look stressed when they don't have enough nitrogen. It's like one of those really obvious things, and farmers then add more fertility. And so we kind of expected like low nitrogen levels and high soil phosphorus and potassium levels. But we actually found really, really high nitrogen levels as well. And so we did all this testing in the spring. It was like April and May before most people had like prepared their soil for the year. Even many of the high tunnels we went to, we tend to not heat high tunnels in Minnesota. And so people, there's some folks who really invested in growing greens in the spring, but many of the people we visited had not yet prepped their beds for the season. So in that context, we were visiting for the most part pre-field prep. And we actually only looked at the top 6 inches. Usually when you do a nitrate test, you go down to 12 or 18 inches. But because we were doing a 6-inch soil test for everything else that we were looking at, we just looked at the top 6 inches for nitrate as well. And in that little spring snapshot of nitrogen, we saw that the average farm had like a 23-pound nitrate credit just in the top 6 inches of their soil. That's like a 18 to 30% of the recommended nitrogen needed to grow a tomato crop in the field. And the average high tunnel had a 125-pound nitrogen credit just in the top 6 inches. And these are adjusted rates. So the amount of nitrogen you need to grow field tomatoes is a lot lower than a high tunnel. And so even with that much higher rate in a tunnel, that's like 36 to 59% of the recommended rate. And that rate differs depending on your soil test and your yield goal. We did kind of like a very loose risk assessment based on nitrogen fertilizer recommendations, or actually regulations from the Minnesota Department of Agriculture. So we looked at hydrologic soil group. So if you had a sandy soil, and then we looked at distance to groundwater, or the depth of groundwater. And then these 2 other factors, we have a lot of karst geology here. So that's like limestone that's really prone to leaching. And then shallow bedrock. So we have areas, especially like along Lake Superior, where the bedrock is super shallow. So looking at those 4 factors, we basically calculated that 2/3 of these farms had a pretty high risk of nitrate leaching. And so we kind of expected to see like a big phosphorus problem going into this project. And then we saw actually maybe we're just really over fertilizing in general, that it's not a balancing issue as much as it's just an issue of kind of understanding what's needed and applying inputs accordingly. I don't know that much about Indiana, but I did find this really nice map of nitrate risk. So if you're in northern Indiana, it seems like you've got some pretty high risk areas of nitrate leaching, as well as it looks like a few rivers maybe. So I'll let you look at that map and make meaning from it. But I think you have these kind of, it's like a double-edged sword, maybe that's not the right word to say, but if you've got sandier soil, you tend to have a higher risk of losing nitrates. Whereas if you have clay soils, you have a higher risk of surface runoff, and then maybe phosphorus loss is like a little bit higher risk. So either way, really careful nutrient management is really important. But your soil type and the kind of environment around you helps to define that risk. All right, so I'm going to transition a little bit and talk more specifically about high tunnels. Um, I see a couple of questions. Let's see. So with folks that are testing and applying compost, do you think it was a disconnect in knowledge of compost as fertilizer or a lack of ability to read the soil test and know what to do with it? I think a little bit of both. I think in general, we're not really thinking of compost as a fertility source. But then there's also this broader issue of people just needing more support to interpret soil tests and make decisions as well. Um, and then another question about seeing a significant correlation between phosphorus runoff and high functioning soils, even if they had high soil phosphorus. So we did not directly measure runoff. We were just looking at the amount of phosphorus in the soil. And I think that would be a great next step. I think in general, there's like, again, the phosphorus loss risk is really related to the loss of soil, to soil erosion. And so soils that are less prone to erosion, that have really good structure, that maybe have surface mulch, that are following those basic soil principles of keeping the soil covered, keeping living roots in the soil, are probably lower risk.
Um, can I ask a follow-up kind of tangent question to that?
Yeah.
One thing that I'm finding with growers in this region is that some of them are concerned about the ecological risks of the phosphorus runoff, but some of them just like, it's kind of like, we're so small that it doesn't really matter. So that ecological conversation just doesn't hit for them. And I'm wondering if you see similar trends in your region as well.
I definitely hear that, like, we're so small, like why are you focusing on us when, like, my neighbor's got 10,000 acres of corn. And I think just acknowledging that, like, that's absolutely valid. But like, I am not a regulator. I'm not here to regulate phosphorus runoff, right? If I were, I might focus on those larger scale farmers. um I think for the most part, people who grow vegetables are people who do have like a desire to farm responsibly and feed their communities, and like want to farm well, um, in the context of like, protecting the environment around them. And so if we can like do the best that we can, I think it's still important and valid. And when we look at the number of farms on the landscape, we have like 3,000 small scale vegetable farms in Minnesota. I'm not sure what the numbers are in Indiana, but if we look at census trends, we are losing farmers in every category, but small scale vegetable farmers are actually increasing. So it's like more and more these are the people who are going to be farming in our future. Um, and I think like even if we're small, why not do the best that we can? I
Yeah,
guess that's my response.
that's beautiful. Thank you. I appreciate it.
And I'll pop in with one more follow-up, which is that, your research is really helpful and what you just shared about that phosphorus runoff risk. One of the challenges that we have is having good data in different kinds of soil environments and management styles to be able to adequately respond to that question, right? And like a grower wants to know, how much risk am I posing and at what
Yeah.
level does it become a problem, right? Like,
Yeah.
so that they can moderate that. So any other research that you have that you can point us to in different kinds of soil environments would be really helpful.
Sure. Yeah, and I'll share at the end a few like a kind of bigger picture strategies as well. But actually the part two of this project was going to 10 farms to do more intensive like landscape level mapping of nutrient movement. Um, And we are still kind of going through that data and figuring out how to make meaning of these like 10 very different case studies. But yeah, I think another compelling argument comes when we start to talk about high tunnel soils, because these practices are not only like, they don't only have like abstract kind of environmental impacts, but they can really impact plant health as well. And we see that most notably in high tunnels. So the first kind of hypothesis that we looked at was this notion that high tunnel soils are depleted. But when we looked at like every measure that you might think about of depletion, organic matter, nutrients, high tunnels had significantly more organic matter and significantly more nutrients than fields did. And so while we are using more nutrients to grow crops in high tunnels, for the most part, people are replacing them in larger quantities than crops are taking them out. And so we did not really see that to be true. Instead, we saw a few things happening. So we saw salt accumulation in about 40% of tunnels. And this is a really common sight where you see this kind of like chalky white salt on the surface of a tunnel. It is worth noting that like as you go deeper, those salts are much less concentrated. Often they are just on the surface, but we saw that about 40% of the tunnels were very slightly saline to moderately saline. We also saw that the pH in high tunnels of the soil like slowly went up over time and was outside of that ideal range for crop production. So the pH was correlated with irrigation water. That I guess like everybody had really high alkalinity in their irrigation water. So it was kind of hard to like, we didn't really have a control group because everybody's irrigation water was way outside of the ideal range. But we did see a correlation between soil pH and irrigation water alkalinity. But we didn't see that with salts. And that's kind of the narrative, I guess, that like we're just using irrigation water, and so all the salts from the water build up in a tunnel. But we didn't see salts increasing over time or with water. Instead, so here are those graphs. Age of tunnel, we didn't really see a relationship. Soil pH, we didn't see a relationship. Water pH and water alkalinity, not super significant relationships. The only thing that was significant was soil nitrate. And so nitrate is a salt. And even calcium, like nitrate was really the thing that we saw driving soluble salts in high tunnels. And so over fertilizing was leading to salt buildup just from inputs in the tunnel. Then the water probably didn't help. So if you have water with a lot of dissolved salts in it, it's kind of like washing a dirty floor with dirty water. Like it's not going to do as good a job of picking up the dirt, right? Because it's already full of dirt. That's like using water with a lot of salts to flush salts out of a tunnel isn't going to be as effective as using rainwater, which has low dissolved salts, but it wasn't necessarily the water that was like depositing those salts in the first place. So yeah, salts and pH were actually problems in high tunnels. The other thing that was a problem in high tunnels was soil moisture. So we did infiltration tests that mimic 1 inch of rainfall. So you take the cylinder and then you take a known volume of water that matches the volume of that cylinder. You pour it in, and that shows you how quickly your soil can absorb 1 inch of water. And then we do it again to mimic a 2nd inch of water. And generally, faster infiltration is seen as a good thing. When our soils are really compact, they don't absorb water well. But it also seems to be true that your soil can absorb water too quickly. So 26% of these tunnels absorbed 1 inch of water in less than 30 seconds. And then 21% absorbed that 2nd inch of water in less than 30 seconds. And what we noticed was that in some cases, we were pouring the water through and it was like the soil was still dry. Like it went all the way through and then it was like still dry on top. And that's actually something that I see often in raised beds in urban farms where like you can take a hose and just be like watering it and you see water coming out the bottom and the soil inside of it is still dry. And so you get these kind of distinct layers where you have compost and then you have soil. And it's tricky because one of the soil health goals is to minimize tillage, right? So there are always trade-offs, but if you're not incorporating it all, you can get this separation of layers um, where compost, when it dries out, becomes hydrophobic. It can actually repel water. And especially in really compact soils or very clay heavy soils, we were noticing this thing where you would have this like dry compost layer and then people would have to water frequently to keep that moist as seeds were germinating. And then the soil underneath would become really saturated. Um, so you get this was my terrible attempt at Photoshop art to make two layers of soil. But we sometimes see in these soils that are using a lot of compost and deep compost mulch systems that these weird kind of water dynamics occur and people really struggle with germination. And then we actually sometimes see plant pathogens like rhizoctonia really start to build up in these systems because we have pathogens that love soil moisture and they love decomposing organic matter. And when we start to get to that like 12-15% organic matter, your soil it's like you've almost created a bog. You haven't, because the acidity is different. It's not a bog, but you have this system of constantly decomposing organic matter. And so these soil-borne pathogens are thriving, and then you just get weird water dynamics. And this was really hard to like meaningfully capture in a data set. It's more just observations. I think the best data that we have showing this is just that really fast infiltration. But it's a dynamic that we see happen often enough. So what do we do with all of this? In part, we need realistic management suggestions for providing nitrogen without all the extra phosphorus and potassium. We're really relying a lot on compost and manure. And so if you're in an educator role, like we really need to make sure that we're giving farmers viable solutions to kind of keep things in check, whether that's using inputs like feather meal and blood meal, using cover crops more and more. But also we are likely over applying nitrogen as well. And so just more support with with interpreting soil tests is super important. Calculating nitrogen credits. I have just learned, I was teaching a high tunnel course this spring and really digging into like old high tunnel research. And there are like our research farm in northern Minnesota that is associated with the university, you can get a 90-pound per acre nitrogen credit just from the water because we have so much soil or so much nitrate contamination in our groundwater. So in high tunnels, especially where you're exclusively irrigating, I think doing nitrate tests of your water, making sure that you're calculating those nitrogen credits from previous manure applications, compost applications, and then doing nitrate tests. We don't usually do nitrate tests in fields just because it's not a super reliable metric. We tend to use organic matter instead. But I think in high tunnels, it's really appropriate to do a pre-season nitrate test. And then if you are using deep compost mulch systems or relying heavily on compost, really sticking with plant-based composts and testing it if possible. And also if you are in an urban environment where you have like a county program, I talked about those kind of really not so good case studies with the salty compost. After that happened, Ramsey County actually gave me funding to go do soil testing at like every community garden that they send compost to. And they then created their own system where they test every batch of compost that they deliver to communities. And so we also need to be finding ways to like take the burden off of individuals, right? It doesn't make sense for 100 people to test the same compost. But if we can be more proactive about having counties do it, or cities, or compost distributors, I think that is a relatively easy thing for us to push for that can benefit a lot of people. I was looking through your website yesterday and I was super excited to find this Indiana nutrient management tool. I have spent a lot of time this winter trying to make something similar, not realizing this existed. I think yours is cooler than mine, but it's also maybe a little more complicated. So we just published a tool on our website where you can kind of choose your crop, put in your soil test info, and then there's like a drop down menu of inputs that are rough estimates of like composted, a bunch of different poultry manure products, yard waste compost, municipal compost, and then it kind of balances out 2 different products to get you a good recommendation. So my tool is a little glitchy, but I think it's getting there and it's better than nothing. And I'm really excited to see that this tool exists for Indiana as well. So the more we can invest in these types of tools to make these decisions easier for farmers, I think it makes a lot more sense than trying to teach like 4-hour workshops where we make people do like 3 hours of math. It just doesn't work. I've tried. So trying to make these decisions easy and user friendly, I think can go a long way. And then beyond just nutrient management in individual fields, I think kind of training ourselves to do some more landscape level risk assessments of like, how is soil moving in this system? So how can we use basic soil health principles in fields like cover crops, mulches, keeping the soil covered, reducing tillage, but then also thinking about the landscape. So are there places we can plant perennials and things like berms and swales, especially around storm drains? Can we make sure that we're like putting in strips of deep rooted perennial vegetation to minimize some of that runoff? And of course, there are great programs through NRCS, soil water conservation districts. I think, at least in our state, we really lack a lot of good examples of small scale farmers using these programs. We have great examples of people using NRCS to build a high tunnel, but we have fewer good examples of these conservation practices. And so the more we can like highlight success stories, I think the more these kinds of things can take off. For salts, I think just careful nutrient management will go a long way in managing salts. And then things like removing the plastic to get some rainwater in there, like every 5th year when you're going to reskin your tunnel. I'm seeing more people build movable high tunnels. I thought a few years ago that this was like not the future of high tunnels, that they're too expensive, they're too prone to wind damage. But I'm kind of changing my mind on that. And NRCS has had like more and more money per square foot allocated towards high tunnels, which actually has allowed some farmers to fund a moving high tunnel, like just with NRCS funds. So that's pretty exciting. I am not a fan of leaching. If you look at like so many extension publications about high tunnel management, they recommend leaching the salts out of your high tunnel. But one, those salts are nitrates. So we're leaching nitrates out of our tunnel. And 2, you just have to be really careful that you're not, it's like the dirty water analogy. If you're leaching your tunnel with water that has very high alkalinity, it's not going to be that effective. So it cannot be effective, and there are implications beyond just, the health of those like 6 inches of topsoil. And then for soil moisture, I know it is not practical to take the plastic off your tunnel every year, but I think taking it off every 4 or 5 years can have positive impacts. Again, movable tunnels, some of the same recommendations for salts can have implications for soil moisture. Cover crops. So these are photos from farmers participating in a winter cover crop trial. Right now, we've got like 40 people across the Midwest and Northeast trying winter cover crops. Just, keeping those soil health principles alive in the winter, keeping living roots in the soil. You have to water your cover crops because they can remove moisture from the soil. But I think having these kind of barren tunnels over the winter every year is not ideal for soil health. That is not like touching any of those soil health principles. So cover crops can not only help us to maintain structure and moisture in the soil, but if we're using legumes, they can give us some of that nitrogen, which becomes so out of balance when we're really relying on compost and manure. And then finding a way to incorporate compost to avoid having those separated layers, I think is also really helpful for preventing issues with irrigation down the road. So in summary, vegetable production seems to be kind of hard on the soil, but conservation practices really do matter. We need to do better, I think, by small scale farmers to help make nutrient management more accessible. And while there are like landscape level effects of over fertilizing in fields, when we get to high tunnels, we really see plant health effects as well. And so more careful nutrient and water management can really help to prevent plant problems and help people like thrive in this system that is a really big investment in terms of both labor and money. So that is all I have prepared today. These are two places, our YouTube channel and our newsletter, where we'll continue to share results from this project. It ended like 2 years ago, but we're still going through data and still kind of figuring out what it all means. So thanks for having me today. I'm going to stop sharing and look at the chat.
Yeah, thank you. There's some questions in there, and the caffeine kicked in, so I have a lot of questions. So yeah, the nutrient management tool, you should definitely connect with Kevin Allison, who is the one that helped create that. I'm happy to send you guys a connecting email so you guys don't have to worry about that.
Okay.
Great. So there's a question, can you explain how to account for nitrate credits?
Yeah, I can send you a link.
Great.
We have a new-ish high tunnel nutrient management webpage that I can link that kind of walks through like all the different nitrate credits. So taking a water sample, doing a soil nitrate test, and then trying to calculate how much nitrogen may still be available from previous applications as well as cover crops.
Awesome. Yeah, I've looked a little bit at that new website and it's fantastic. Well done, guys. That's beautiful. In that, I didn't see, so do you have any recommendations for good resources for cover crops specifically in high tunnels?
We're working on it.
Awesome.
So I'm working with Julie Grossman's lab and Becky Seidman's lab in New Hampshire. And they have some like kind of like best bet legume cover crop species that they in general recommend, but we're now like testing those on farms across the country to see like does what we found in our trial, like our very detailed replicated trial, but in like 1 or 2 high tunnels actually makes sense when we look at it on a larger scale. So if anyone is interested in participating in that project, it's all legume cover crops, but we're going to have people planting in the summertime slot. So there are folks that like really just focus on the shoulder seasons and then have their high tunnel open in the summer. And then most people do the fall time slot. So they plant in like October and then terminate like a couple weeks ago. And then we have this little spring slot for people who do like winter spinach to see if we can get a benefit from a cover crop that's there for just like a month or 2. So we're like entering the first summer of that project and we're going to do it for another year. So if anyone's interested, we send you free seed. We have some farms that are doing more intensive data collection, but then we have this like low barrier trial where we'll just send you seed and then you like kind of give us a thumbs up. You fill out like a 5-minute survey that tells us like how it established, did it survive, etc.
Oh, that sounds beautiful for some of the more busy farmers that still want to participate. Perfect. Yeah, I put that on my list. I'll make sure to follow up and get that information for you, and we can send it out in our network. There's also a question, how do cover crops help in access nutrient management?
Yeah, so basically there are a couple of ways that cover crops help. So one is if you just need to add nitrogen to a system, like you have plenty of phosphorus, plenty of potassium, and you need some nitrogen, using a legume cover crop is a really nice way to get nitrogen into that system. Those legumes are pulling nitrogen out of the atmosphere, putting it in your soil. We have other things you can apply, like blood meal, feather meal. Um, Blood meal's sticky and weird and gross. It's a really good tool, but like it's not the universal solution. Like apply 1,000 pounds of blood meal. And so cover crops can give you like a lot of that nitrogen. The other way they help is because they have living roots. They're growing like in the off season where your field might just be bare. Your the nitrogen in your soil is really likely to leach out of the soil. And so by having something that's living and using that nitrogen, even if it's not a legume, you're kind of keeping it there in the upper soil profile. And then when that cover crop dies, you're putting it back into the soil. Um, and so you're like keeping the nitrogen in the system, even if you're not adding more. And it also, like having living roots in the soil, helps to prevent soil erosion as well. So it helps to prevent the movement of nutrients through surface runoff.
Have you noticed anything with cover crops helping in taking up extra phosphorus and potassium?
So they will take up that phosphorus and potassium as they grow, but then you're like returning a cover crop back to the soil. And so you're not really taking it out of the system. Um, I think like that you could like mine phosphorus out of the soil. But you're kind of doing that just by growing vegetables too. So like your crops are taking up that phosphorus slowly. Um, and just kind of, yeah, I think just slowly drying it down without adding more is kind of the probably the most recommended approach or the most practical approach. And then doing as much as you can to focus on soil health and prevent erosion.
And then I had one more question, like just the irrigation water. Do you guys have any best practices, management recommendations for the irrigation water that's a little wonky, high alkaline, nitrates, all of that?
Yeah, it's okay. It's really tricky because in the short term, there are things you can do. So if you have like high pH in your water and high alkalinity, well, okay, I'm gonna back up. It's it's awkward because we talk about high pH as being alkaline, but they're two different measurements. Alkalinity is a different measurement than pH. If the pH of your water is high, you can add acid to your water to bring it down. And that works very well in like the immediate term for changing the pH of that water. In the greenhouse industry, this is super common. People tend to use sulfuric acid and nitric acid. On certified organic farms, the only way you are allowed to acidify your water is with certified organic citric acid. And there are like three different ways, I think, of making citric acid. So only one of those ways through natural fermentation is approved. So it's not just any citric acid. You've got to choose the right one. And I think in some cases that is appropriate. The tricky thing is you may, in the longer term, be contributing to like more salt buildup in your soil. So it's like a really tricky trade-off. And I think that was initially my thought with this trial. It's like everyone's got to acidify their irrigation water. And then some of the soil scientists I talked to were like, be careful with that recommendation. And their recommendation was more just like, you just need to get some rainwater into those tunnels. And so go back to the basics of recommending like taking the plastic off every 5 years. Some people will like, if you've got a snow plow and a lot of snow, they'll like plow snow into their tunnels to get some snow in there, or the movable tunnels. So it's kind of a trade-off. having irrigation water that has a really high pH can limit nutrient uptake. And so I think it's a tool to use, but it's one that should be used in a broader context of like keeping your pH and your soil, your salts kind of in check in other ways as well. And then the other tool is using sulfur to bring the pH down. But
Of the
that's not gonna
soil.
be in your water. Yeah, that's in your soil.
Okay. Okay. Also, you kind of blew my mind just before. High pH and alkalinity is different. Is that an easy conversation for you to quick clarify?
I don't want to say the wrong thing. So your
I
pH
can
is
Google
like
it
a
too.
measure of the acidity, and then the alkalinity is kind of a measure of like dissolved solids, and it has to do with hydrogen buffering capacity.
Okay. All right. That makes sense. I'm getting reminded of some chemistry classes now.
Yep.
Perfect.
And there's an
Awesome.
ideal range. So the ideal pH for irrigation water is like, I think 5.8 to maybe 7, 5.8 to 6.8. And then you want your irrigation water to have alkalinity less than 100. And at least so we have a lot of calcium carbonate in the bedrock. That's just the basic like geology of Minnesota. And so alkalinity is like 300 on a lot of farms. It's super high. I don't know what your bedrock is made of in Indiana. Along the North Shore, where we have more granite, we don't have that same problem. And so it's one of those things that like it just is what it is. It's based on your basic soil geology and the bedrock geology. It's not something that like you've done or have that much control over through management.
Yeah. Awesome. Gosh, I really appreciate you joining us this morning. Thank you so much. I'll send a follow-up email
for having
and
me.
hopefully get folks some more information. This work is so valuable and so interesting. Thank you for exploring it. This has been
Thanks.
fantastic. So thank you. You're welcome to stick around. We're gonna just do a few updates of our program and tie up the rest of this meeting here. So thank you.
We'll probably head out then. Thanks.
All right, take care. All right. There we go. So next we're gonna go for our regional highlights. And we're gonna start off with Ellie with the statewide.
Thanks. Little bit of an abrupt transition, right, from technical topic to more programmatic, but the big takeaway is just want to be fully transparent about where we are as a program coming into this year and moving forward for the rest of the year. So our federal funding had been up and down, and only as of the very end of April, we do have the news, thankfully, that all of our current federal funding has been restored from different buckets. So we're incredibly grateful for that. And thank you to our NRCS partners at our state level for navigating those challenges and supporting us and really advocating for us through this process. So those federal funds carry through the end of this fiscal year, September of this year, and this is coming up on the end of our first 5-year agreement with NRCS. We came into this year poised in conversations with our, statewide leadership to continue our mission and our work and even expand our program. And we've had to adapt and be nimble and continue to, navigate this new year together. I want to also extend a thank you to Clean Water Indiana and any individual districts that might be on this call. There are a number of individual county conservation districts, soil and water districts that have sent in funds as part of their original 5-year match towards our program. So those dollars are being invested in us and then going right back out the door to help support working groups and events and technical assistance on the ground. So kind of looking ahead for this year, we're in a kind of a weird phase of being back to business as usual for our program managers, our US specialists in the 4 different quadrants and our events. We can, support events, come and visit you in your local district, do site visits, do soil tests. But then we're also really thinking about how to navigate continuing beyond September. And so anyone that is on this call that has any ideas for additional grant funding, strategic partnerships, and ways to, catalyze investments to continue us beyond September, I'd be eternally grateful and happy to chat with just anyone that wants to talk about what we're experiencing and, think about that next phase. And we do have close to 50,000 that is allocated towards our local working groups for this year. So that does continue with the seed funding of this program to let local districts and working groups create their own events and pay incentive payments for site visits and TA. But we're really in this phase of encouraging and supporting those local working groups to think about that next phase of sustainability, so kind of the same boat that we're in. What other partnerships can be leveraged? Who else can be brought into those local working groups to help continue with that next phase for them. So thank you. Open to questions. Open to talk at any point.
Thanks, Ellie.
Yeah.
Next, we'll move on to the Northwest.
All right. So the Northwest is just full of energy with this spring. We had Montgomery County's a local working group hold a site visit here at Juniper Spoon, and the farm has a big garden. They've been practicing no-till ever since I want to say about 15 years ago, almost 20 years. So layering on cardboard, just organic material from the lawns. And so I thought it was a prime place to check out the soil and do some technical training and teaching for these future members of the group to go out and do site visits around the county. And so we did infiltration tests to see how quickly the water went through, looked at different ways to assess the soil and take notes, ask questions. And that was just really exciting. And I think the group is really excited and starting to get more and more questions from small scale gardeners and farmers about improving their soil tests, getting their soil tested and improving their soil health conditions. So that's really exciting. And then the Lake County local working group also just recently held their Growing with Contaminated Soils workshop. And that went really well. There was a good turnout and people were really engaged. There's a lot of lead contamination up in the Northwest in Lake County region. And most gardeners are growing with raised beds for that reason. But there's still curiosity about what's going on with your contaminated soils and how to proceed with precaution, make sure that your people are being safe as they're trying to grow food. And there were a lot of different experts from ISDA, Purdue Extension, SWCD, different conservation partners who came together to provide that expertise on technical information. And we're in the talks of maybe getting free lead testing happening through the libraries in Gary and in Lake County. So that's exciting. And then it was really great to meet other SWCD people, old and new, as we kind of talked about what went well during the annual meetings. And also, Kevin Allison gave a really great presentation about cover cropping. And so went through the calculator. And so the SWCD's representatives are feeling a little bit more equipped to navigate this the next few months. And got to go to table at the Springdale neighborhood event in Indy. And it was really cool to see so many different people come up and ask questions, and there was definitely themes. So squash beetle bugs, and what do I do with my small patch of shaded slopey grass, and do I have contaminated soils? So if people hold events that bring people together, you can kind of find a lot of themes, what everyone is facing together. And the pictures here, the bottom left is just a volunteer event that Wabash College held to promote education about native plants in rain gardens. So all these people showed up, and we planted almost over 100 different types of native plants in this rain garden feature, which completes that whole area. So that was really exciting. And then the picture on the right is under a high tunnel in Tippecanoe County, where we're prepping for a field day that will happen where we talk about native pollinator plantings around high tunnels. But we took a peek inside the high tunnel and kind of talked about soil health and what that looks like. So today's conversation from Natalie was really, really, really relevant. So yeah, lots of things coming, lots of site visits and soil testing happening, and more to come. So thank you guys.
Thank you, Tanvi. The unmute button wasn't showing up for me, which I'm sure there's a couple people that wouldn't mind that. So Northeast highlight. I've been doing lots of wonderful site visits and different events throughout the Northeast, but the highlight I want to focus on for you folks was in April, there was a small farm field day in Allen County. So it was the inaugural small farm field day for Allen County Soil and Water. It was at the Wolf Center, which is part of Solomon Farm. And it was a full day. There were more of the classroom style in the morning, where you can see the inside of this building set up for more lecture style with different growers and advocates of soil and soil health. It was a lot of fun seeing a lot of different speakers there. And we got to also have a table. I gave out lots of resources, lots of our information that we have, lots of really great conversations. The more lecture style was from a bunch of different growers. This was one of the first ones that were talking of a farm in Ohio, just over the state line. We also had people talk about compost and soil health, and then it ended with right before lunch, a microscope up on the big screen and looking at soil biology and the different organisms in there. And it was a lot of fun being able to see people like nerd out over what you can see in a microscope of different kinds of soils. And it was really interesting to be in a group of people that were just really excited to look at those things. After a really amazing lunch, we then went outside, got to look at the different fields around Solomon Farm Park, look at the different kinds of soil, and have conversations from two different farmers from Allen County. This is Mr. Munsinger, and he has become to love really great soil health practices for his commodities, and just kind of talking about the way that he grows through that. And then we also had another grower, Carrie, who does livestock and rotational grazing, and really ingrained in the soil health and what it does, and hearing his perspective on that. And afterwards we had just kind of an open house trade show. It was very well done, and I really appreciate the work that Allen County Soil and Water did on this to bring together like-minded individuals to talk about small farms and soil health. It was a lot of fun. So that was my big highlight from the Northeast for this past month. Tanvi, would you like to talk about the Southwest?
Yeah, Casey's having some car problems, so she apologizes that she can't be here right now. But so she was in Vigo County where she did a field day site visit and took samples. And as you can tell, there are different practices that are happening in these kind of like greenhouses just to see what is growing in the different soils and season extension. And they have kind of like a big range and diversity on this farm. And so they're trying out, the soil test will show what they're going to prep, how they're going to prep for their future garden and farm space. So that's it.
Hey
And
all,
the
this is Megan with the Southeast region. And I just wanted to share a little bit about what's coming up in our region. I've been working with lots of growers trying to help them through this interesting time with regard to federal funding, helping them navigate, and just giving them pep talks if their reimbursements are coming slowly. But this weekend on Saturday, we're really excited to learn more about pollinators and the plot master in Ohio County. They're installing a large pollinator habitat that is open for the public. So if you're interested, make sure you reach out to Ohio County Soil and Water Conservation District, and that'll start at 2 p.m. on Saturday. Additionally, there's going to be some really interesting invasive species learning opportunities out of Dearborn County, but it is virtual. So on the 14th from 6 to 7, you can pop in. So if you're interested in getting that link, make sure you talk to the Dearborn County Soil and Water Conservation District. And then a couple of weeks ago, I did a no-till small scale farming workshop on my farm. And that's the picture on the far right with one of my cats who snuck into the high tunnel. And we were talking about utilizing plant-based composts as mulch, as well as utilizing other things for mulches. And you can see that my high tunnel already early in the season is very overgrown. So we talked a lot about preventing issues like this, for instance, tarping, utilizing cover crops, that sort of thing. But the people who came had a great time, and I wanted to thank PIF, Partners in Food and Farming. They were great partners on that event, and we had a good time, and the cats enjoyed meeting new people. So we had a lovely time. And then farther north in the state, if you're interested, but you probably won't be because this is for the high school students, but in the Vernon Township trustee compost project, we're going to be working with seniors at the high school to create a large scale community composting facility for people to drop off their plant materials. So we're really excited about that. And that'll be happening on May 22nd during the day. So if anyone's interested in anything, you can reach out to me. You can reach out to those soil and water conservation districts who are supporting this really great educational outreach. And again, if you want me to tag along with a site visit, or if you have questions, feel free to reach out. We're still as passionate as ever moving forward, regardless of funding streams. So thanks a lot, and hopefully I see you guys out there.
Thanks, Megan. So just a few more upcoming events. All of these, most of these can be found in our newsletter. So if you sign up for a newsletter, you can find these. You can also find it on our website under the newsletter tab. But we've got some good events coming up. Megan just talked about the Plot Master and Pollinator Garden Workshop. Next week, there's a small farm tours in South Bend on Tuesday, so 2 different farms. Just being able to get on the farm, talk directly with farmers, networking. One will be at Sunchoke Farm, truly urban. Susan does an amazing job there, and also has composting facility, microgreen. She's really diversified, super cool. And then the second one is at Patrick Kowalski's farm, who does like a veggie farm stand, a lot of diversified veg. And he, and I think it's about 10 acres. So it's a really diverse 2 different farms to be able to visit. It's free to attend, so sign up if you guys want to attend. There's the invasive species learning series that you guys heard about. The Veterans in Farming is doing an equip high tunnel build at Jack's Farm on May 14th and 15th. We've got the beneficial insect habitat on small farms. Townview is out there doing some prep earlier this week, getting all of the beautiful plants to be growing for this. We've also got the Soil Health Working Group Summit that's going to be coming up. So any folks that have a soil health working group that want to be able to help come together, network, and then also see Kevin Allison's garden plot in the afternoon, sign up for that. The Living Farm series that we've been promoting for the last couple of months starts in July. More information on that on our website as well. And then the Veterans in Farming Conference is coming up in July. So we'll be continuing to add. We've got a couple of people in the chat that have put a couple of different events as well to look at, to put your attention on. And this is where you can do any partner share. So would anyone like to unmute and talk with us about their events, or you're welcome to put it in the chat.
Hi, everybody. It's Julie from Allen County. Thanks, Terry, for the shout outs on the events. Elissa Lewis did a great job and just really had a fun day. She wanted to get partners together, and that's, I think, what really happened. So, but I also wanted to thank Columbia City and Wabash for doing an invasives training. I know it's not strictly urban, but it's really becoming a huge effort in the urban spaces. And so we've been going last night, well, Monday night, and then 2 more Monday nights. And so Jeff, I think his name is Shortgen. He's been training us along with John, both Purdue Extension. But I just wanted to say thank you to that. And there's lots of that going on. And if anybody knows of a Fort Wayne based or Allen County based group for SICM or SISMA, and you could let me know, that'd be great. I know they're rebuilding here locally, but if you know anybody else, I appreciate it. So thank you. Sorry.
Thanks, Julie. Anyone else? All right. Thanks everybody for sticking around. It has been a lot of fun. I hope you guys learned lots. Our next one is June 4th. And again, we'll have a speaker from out of state. So from Cornell, we'll have Lori Connick coming, and she'll be exploring management practices for high organic matter soils and high tunnels in urban farms. Really fun speaker. I think you'll have a lot of fun with that presentation as well. So we look forward to seeing you on June 4th.